Hello, everyone. If there is a prize for the longest title of a presentation, I think I'll be the winner today. Today I'm representing the XT House. We're a construction tech consultancy firm specialized in algorithmic design. We cover the full spectrum of construction industry, working with manufacturers, consultants, developers, and contractors. So I'll talk about highlighting the necessity of building envelope DFMA using algorithmic design in a BIM workflow. My name is Ayoub. I'm the director of digital construction in the XT House. I started my career as an architect, and I learned how to do some programming and got into the automation and built a community around that at the XT House. So I'll start by showing you something maybe that is very familiar for the most of you here looking at this, which is the development of LOD. And I think it's one of these things that are controversial in our industry because everybody says LOD represents something different. Some of them call it LOD, level of development. Some of them call it LOD of level of details. And I wanted to reflect something also controversial, which is the theory of evolution, and how nowadays we're discussing this controversial thing with something that we want to exist in, which is the metaverse. So that's an avatar that can represent somebody in the metaverse, in a digital world. Well, we all know how it can go in our industry. It can go very wrong like that, from design into as-built. And we want to try to probably avoid that in our projects, and that's why we're all here. So just to give a definition to the DFMA, which is Design for Fabrication, Manufacturing, and Assembly, it's basically a process to streamline the process of all the way from design to installation. So it goes from design, fabrication, manufacturing, and assembly, and using a single source of truth where you can do all your engineering and design development while maintaining the needs of logistics for actually fabricating these elements of the building that you're building. As familiar as we are with the BIM benefits, I think we need to keep these venues really also showcasing the basic knowledge of what BIM is and what does it bring to the table, because we always come here assuming that everybody is expert and we want to speak on those buzzwords and terminologies, but I think it's also good to kind of bring that to the table, which is self-explanatory here. I'll start by talking about one of our recent projects as an example for DFMA, which is a project in Australia in the city of Melbourne. This is Melbourne Quarter Tower, which we did in collaboration with Land Lease and Kingspan. And this project was actually specified to become delivered through DFMA. This is a quick video showcasing how does the DFMA was planned to be delivered. So I'll try to kind of skip through it very quickly to make it faster, as it's going to take some time. But this is the DFMA definition, and then I'll try to use the... Sorry. I think I can't do that, yeah? Oh, sorry. Okay. Starting from the beginning, yeah, that's right. It's right, if you be patient with me, I'll go through it very quickly. So Melbourne Quarter, this particular DFMA is going to highlight the building envelope for the roof. The roof here was designed in a way where it's curved and very complex. And the reason why architects designed it in this shape was to maintain the regulation of shades and light for the neighborhood. And you can see here all these segments around the roof is segregated through different setups of components using a system called standing seam roofing, which consists of multi-layered system that is being highlighted here for each component of the roof. So these are the structural elements that you can see from the screen, and then you will see how these are being taken into an off-site manufacturing facility using the same measures and and geometry boundaries, they will start building all the building roof components, putting all the safety requirements through this handrail, and then you get your first layer of the roof and develop that through these units. And each one of these units will have this setup of the roof layers. It will be built off-site like this. And then you get the gutters around these areas, which is for the rainwater management. And this showcases the layers of the roof that is being installed there. So you can imagine how having this complicated roof setup being installed on top of the roof on such height. So there is also an element of safety you can bring in with these kind of processes of DFMA. It's not just about mainstreaming the timeline and the cost, but also to deliver on time with higher safety measures on this case, for example. So right now, after you've set up all the components of the roof for these units, these will be removed and then kind of stored on the facility. And then once you go to the building and build it all the way and reach the roof level, which this 4D simulation is showing that. Right now, we'll reach up to the roof, I guess. Yeah. Almost there to the roof. There we are. So this is the stage where you take these components, which is the main structural element, ship them through the trucks to the site, and then lift these elements all the way up to the roof, install them one by one until you have a proper place to start laying down your units which you've built previously on the manufacturing facility. There it is. Right, that's where you start with the sequence of what comes first, which is the box gutter, and then next will be the roof build-up units, which with the skylights, which will be installed in a second right here. So we've got a few seconds on this, and I think we can skip to the next one. Right, so that's the installation of the final build-ups. Easy at the end. This is the building BIM model that we came up with at the end to mainstream that. Just to give you a perspective on how these were developed internally within the BIM environment, this is a shop drawing sheet that shows the components of the final layer of the sheet, which is the standing seam sheet itself. So manufacturing facilities needs to have these cut lists to kind of produce it and then install it in line with the accessories behind it. All these accessories that holds this roof is structurally designed and engineered to maintain the criteria of the building envelope, which is maintaining the roof thermally, acoustically, structurally, and etc. So there's a lot of challenges that led into these opportunities of safety measures that we went through, which I mentioned earlier through the geometric challenge and etc. This is another project I've done during my employment with Kingspan, which I used to be an employee there. This is Etihad Arena project, which was executed by BAM as a main contractor. It's an award-winning project, and you can see the complexity of interfacing of the faces on the building envelope here. So the challenges here were translated through the geometric challenge as well, and adaptability to a very, very difficult tight line, and to maintain the needs of the fabrication and manufacturing and all the way through that. But what we had here different from Quarter Tower was the laser scanning element, because during the execution, the steel was not really in line with the design earlier, so we had to go to the site again, capture what's on site, and translate it into the design environment, and then develop it again. So all what we got at the beginning was just a small, smooth surface that doesn't have even the build-up of the roof. So we developed that through the algorithmic design using these roof build-up strategies, and built it through the scripting tools to automate all these build-ups to be issued with the data related to it. This is an example of the shop drawings that came through it. And this is how much messy it was on site. Everybody was working around it. And until the end, we were able to also highlight the interfaces which needed to be customized at the meeting points at the edges of each surface. And that's the laser scanning project. And if this can remind me of anything from the surface to the end delivery is the evolution, which is the controversial part I was mentioning earlier. So this is the final result of the project. It's currently running. If you're a fan of MMA, a lot of fights are happening there with MMA champions. This was just for fun that I tried through Midjourney. It was a post we posted in International Women's Day which reflects the environment of the Middle East somehow. So, yeah, this is another project I've done during my employment with Kingspan, which is Kuwait Airport. I'll mention it in a very high level very quickly as well. It's one of the largest airports in the Middle East. We're talking about an area of 42 football fields. And one of the elements that I want to highlight from the automation part we've done here, working with Foster and Partners Architects and the contractor Limac on that project. And I was working here with Kingspan during the time with my team. We did highlight one of these bigger challenges, which is the skylight. If you see this build-up on the funnel on the left-hand side, this is a funnel that goes through the roof attic. There is 7,922 of these funnels in the project, and they're all different in height and widths. So the only way to do it was to build one prototype, have some adaptive points with formulas that can script this prototype and mainstream it through all the locations of these skylights locations. On that element of the brass cladding around it, we saved around $5 million just from the waste, because we're cutting the brass material using the right cutlass. Wherever we cut from the raw material, we can use it maybe in some other parts of the building. There were other savings in other parts, but the brass was the only thing we could measure with money, because it was easy to measure with the raw material price. But the cost saving that we've done around the building envelope overall was far, far more than that, in my opinion. Just to put it into perspective of scale, this is a scale of the labor for the top part of what I just showed you. It's quite massive. That's the skeleton that I showed you earlier for how did we script the design to become rich with data to be exported and delivered at the end. These are all processes of the building envelope layers that I was talking about earlier, so it's very similar. So that's how the material starts. It comes as raw material, and then you issue it as a final cut list that you can just take on to the site and install precisely. This is the project when it started in August. This is my first visit to Kuwait. That's actually the project you can see there, still having the foundation being built and some structures. And that was it when it was finally built, which was quite emotional to see that kind of picture after a number of years working on these developments with large teams around Ayoub, Foster and Partners, and Limac, the contractor, and Kingspan, of course. We used the Power BI dashboard here to reflect all real-time data that was generated through the process. So during the process of working on this project, you will always get questions of where are we in terms of progress in the design part, fabrication part, having the cutlass issued part. So we had some parameters pointed within our modeling to showcase these parameters, to show you how much is issued for fabrication, how much is delivered, how much is ready for ready engineering for fabrication. So all these stages were kind of very handy to showcase to high management and to the client and keep everybody informed about where we are. Another project, very on a high level, Boston Airport, also with Kingspan. We've done the King's Cross You can see the very complicated sheets here of substructure for the roof, which was built in a way to maintain a geometric challenge where the roof was not actually parallel with the roof, so it's deviating in terms of thickness. So all these precise cut-list components were issued through a sophisticated algorithmic design tool that we built internally to be able to achieve that. That was how it's delivered at the end. All was capturing in detail the interfaces and making a robust system as a roof. As you can imagine, for a roof on an airport, it has to be highly engineered and delivered with all the engineering involved for these interfaces. I also tried this for fun on the Boston Airport mid-journey. It was inspiring me that this is more like a Spider-Man home. So yeah, just for fun. So all these processes we've been doing, we built in it through our internal workflow, which we call the kitchen. We are trying to use as much useful platforms that are coming up. You can come to these venues and always see new platforms are dominating the market. Hopefully we can add Rivisto there as well to kind of make it stronger, since you are the sponsor of this stage. So the areas of investment that you need to include in such can all be tailored in a way where it can fit your deliverable needs. I think every organization nowadays needs to have this conversation internally. Where are the areas of investments we need to focus on, and what are we expecting to deliver? And that's what we were trying to do all the way. And of course, it's not just the direct benefit of the company. We're all part of the community here. Everybody's talking about the ESG categories we would try to be aligned with. And of course, doing anything around automation and will contribute to sustainability, to save resources, and be aligned with the international schemes of ESG and etc. So that was my presentation. Thank you for listening. And you can connect with me here on the QR code on LinkedIn. And thank you for listening. Cheers.